All right, so here's some more review. How far did you guys get? Did you want me to go through some of these?
We do like 4 or 6.
4 or 6, sure. Okay. Going to take a look at this, all right? What I do, you want to work on the right or the left?
Left.
The left, okay. So what I do is I take a look at the left and I take a look at the right and I ask myself, on the right, what does it seem as though I need to change my cosecants to?
Cotangents.
That's right, I need to change them to cotangents. So then, I take out my identity sheet, and I look to see if there's a relationship between cosecants and cotangents.
Hey, what do you know?
And what is the relationship?
Cotangent squared plus 1
Equals,
cosecant squared.
okay, all right, so what I've got there now, so what we do is we take a look at this, and we see these need to change. All right, so next step, can you replace cosecant squared? How does that relate to cosecant to the 4th?
Divided by 2.
Well, it's a little bit divided by 2. For example, how is x squared related to x to the 4th? What will I need to do to x squared to get x to the 4th?
Square it again.
Square it. So you can rewrite this as cosecant squared of theta squared minus cosecant squared of theta. Okay? All right, next step. Should I replace this with all of that up there?
I think you should, yeah.
All right, so let's try that.
Hey, what do you know?
Cotangent squared of theta plus 1 squared minus all right. You have to be very careful that you distribute the negative into everything. Now, how would you square this thing right here? Gonna have to use FOIL. Okay, so right over on the side, I'm going to say cotangent squared of theta plus 1 might be a better way. I think this might not be a very good way. Maybe. All right, so this is cotangent to the 4th of theta plus 2 cotangent squareds of theta plus 1 minus cotangent squared of theta minus 1. I distributed the negative inside. Does everybody see that? All right. Now, can we simplify it after this?
Wait, if you distributed the negative.
Yep.
Oh, just into the last part?
Just into the
Oh,
second,
okay.
because the negative was right before the parentheses, and so I made that negative and then made that one negative. Okay? And this stuff right here came from over there, came from multiplying. Okay? All right. Can anybody see anything that we might be able to do to simplify that? Yes, good. Cancel the ones, perfect. And how many cotangent squareds do I have here?
Can't you just change up to like 1 cotangent squared?
Yep, because I have 2 of them here. So if I have 2 cotangent squareds and I take away 1 cotangent squared, I end up with and this is exactly what we get. Smiley face. Should we do a different one? Okay. Choose one so that we could.
Number 6.
6. Okay. All right, so we did 4, and now we're going to do 6. Okay, take a look at the left, take a look at the right. What's wrong with the left so that it should be more like the right?
Is it always like that?
Yes, pretty much, that's a good point. Yes, pretty much you're always going to work at the left and then go to the right and make it look like the right. So Taylor, what do you see about the left that,
I see 5 plus 3 is 8. So you could do something like that.
okay, look at the trig functions. What kind of trig functions do I have on the left?
You need a cotangent on the right.
Okay, well, or we have to get rid of the cotangent on the left.
Yeah.
Okay,
So you should probably change the cosecant to cotangent and then just take 3 away.
or maybe we should change the cotangent to cosecant.
That's what I meant.
Okay, all right. So this was the identity from up above, right up here. Okay, this identity that we wrote down. Cotangent squared plus 1 equals cosecant squared. All right. So if I want to get rid of the cotangent squared, what does cotangent squared of theta equal?
Cosecant squared plus 1.
No, it's cosecant squared minus 1.
Oh, yeah.
Okay, so I'm going to put all of this in for the cotangent. Okay. What might be a good idea to do next? I have parentheses. How do I get rid of those parentheses? Okay, you're right, I'm going to have to distribute that in. And when I distribute it in, what do I need to be careful of? Okay, what am I multiplying inside? Not just a 3, but a -3. So this is going to be a -3 cosecant squared of theta. And what is this thing on the end going to be? +3. Oh, well, if I have 8 cosecant squareds minus 3 cosecant squareds, how many do I have? There we go. Okay, let's do a different one. You want to give 5 a shot?
Yeah.
Okay. Take a look at 5. Take a look at the left and a look at the right. What is your first stab in the dark that you might want to do with cosecant and cotangent?
Change everything to sine and cosine.
Let's do that. Let's change everything to sines and cosines. Marcy, do you remember cosecant? What is that equal to in terms of sine and cosine? Perfect, yep. So this is 1 over sine of x plus. Taylor, do you know what cotangent is?
Cosine.
Over?
1.
That's right. Okay, now what do you notice about the left? You have what?
Common denominator.
We have a common denominator, so we can actually put them together, can't we?
Yep.
Okay, so we end up with 1 . Oh, wow. Okay, it's not exactly like what we have on the left, is it?
No.
No,
But
so
it's close.
it is close. I've got a sine, I've got a
Why don't you just switch it?
I can't.
Conjugate.
That would be a cool thing to do, to be able to switch it. What do I need in the denominator? What do I need in the denominator?
You need a negative 1
Then
No.
you need a 1 minus cosine.
So, you know what? Let's multiply top and bottom by that.
Alright.
Oh, hey, do you remember? What is 1 minus cosine times 1 plus cosine? Christian, you remember that?
What?
When I multiply these two things, they're exactly the same, but the symbols are opposite.
Yeah.
What if I boxed them or foiled them or multiplied them, what would I get?
Cosine. Right.
1 times 1.
1. Minus. Cosine.
Square root of x.
Cosine.
And now in the denominator, leave it separate. All right, Christian, I'm going to ask you again. What does 1 minus cosine squared equal? Think about the identities.
Sine.
Squared. Lindsay, can you see anything that we can do to simplify from here? Yep, I can get rid of one of these signs and one of those. Okay. Are you feeling a little more comfortable about these?
Yeah.
I mean, it's all about just getting those identities, working them through, and doing all of that. Okay. And here, they give you at the top some guidelines, things to maybe try to do. Okay? I'll put that on your note card as guidelines. That would be good. All right. Now we're on the sum and difference ones. Okay? Let's take a look at number 2 here. 105 is not a special triangle, is it? No, but what two special angles equal 105? Okay, now if I look on my identity sheet, what is tangent of A plus B?
That would be tan of 60 plus tan of 35 over 1 minus tan of 60 times tan of 35.
Okay. What would be important to have on your note card if you don't have them memorized? The special triangles.
Wait, so are we gonna get that sheet or not?
Oh, this sheet right here? Do you want me to give it to you now with a blank side?
Yeah.
Okay. And then you can fill it in, because, yeah, these are the, but you
Wait,
cannot,
so what is this at?
come on, but you cannot put the ratio identities on here. Do you know what I'm saying?
Mm-hmm.
Okay. Is this Brandon?
Yep.
This is just one with the one that you can put on there.
Wait, how do you figure out like what you need to do?
That's gonna take me more than a few minutes and I'm recording, so I don't wanna stop and figure that for you. Sorry. Okay. So to remember, we also need, okay, here's my special triangles. This one is my 45, 45. And what are the sides of it?
1 square root of 3.
And my special triangle are
1 square root of 3 and 2.
okay. Okay, using that information, what is the tangent of 60 degrees? Go to here, square root 3 over 1, which is just the square root of 3. And what's tangent of 45? Yep, so it's just 1. And then I have 1 minus. Tangent of 60 is, again, square root of 3 times 1. So it's just that. So then that would be your answer. If you really wanted to simplify this and get the square root out of the denominator. Does anybody have any ideas how we would get rid of that square root in the denominator?
Times by square root 3.
Not just a square root 3, because if I times it by the square root 3, then that I would have to also times the 1 by it.
Oh, yeah, that's true.
The what? Not quite 1 minus the square root of 3.
1 plus
Yep, yeah, that is correct, the conjugate. You would have to say 1 plus the square root of 3. And then that would simplify to 1 minus 3 in the denominator. And then in the numerator, I would have 3 plus 2 root 3 plus 1. And that would all simplify to 4 plus 2.
Now you're going to want us to do that on the top.
No, if you get to this part, I'm okay with that. I'd probably give you extra bonus points if you were able to reduce this down to that. To that right there. That would be your final answer. What is this the definition of? If you look on your sheet, Christian, can you tell me what that's the definition of? It's got the sine and the cosine, and then a plus, and then a cosine and a sine.
Not really the same.
Look near the top.
The top one?
Which is sine of what?
Sounds different.
Yep. And this is the definition of the sine of 40 plus 20, which is equal to the sine of 60. And since I already have these special triangles on my paper, I look, and what is the sine of 60 degrees?
It would be square root 3 over 2.
Yep. I think that you guys don't have too much of a problem doing these, do you? I mean,
The ones where you have to do where it starts like number 5 are easy, but like the ones that start off with like number 2, those are a little bit more tricky.
okay, what would you break up 4 into?
30 minus 45 maybe.
Okay, so this would be, well, first of all, can we change this to 1 over sine of negative 15 degrees?
Yeah.
Which is 1 over sine, and then you said 30 minus 45. Okay. And then you would just use your definition to go through that, okay?
So what would you plug in the whole thing for each U or V?
No.
Would you just plug in 45?
Well, is this, first of all, this is a subtraction one. So you would go to your sheet and you would use the bottom part, cosine of u minus v. So it would be cosine of 30, cosine of 45, plus sine of 30, sine of 45. And it'd be just 1 over all of that.
Oh, so you were just getting it to sign the, so you could use one of the lines.
Oh, yes, yes. And I'm sorry, I probably pointed to cosine. I meant to point to sine. So it would be sine of 30, cosine of 45, minus cosine of 30, sine of 45. And it's just 1 over all of that. And then you would use the special triangles to get a value for the sine of 30 and the cosine of 45, and so on. Okay? Pardon me? All right, I'm gonna flip the page real quick. If you don't, does everybody have that? How would I do 3? All right, 3 gets tricky because we've got radians and they're in 12ths. One of the things that you might want to put on your note sheet, okay, and I think we started this off. We started off with pi. Pi is equal to, what? Yes, it does equal a 180 degrees, but when we do things in fractions, pi equals 2 pi over 2. It equals 3 pi over 3.
4 pi over 4.
And that, okay? Now, pi over 2 equals, if I want to write it, I can't write it in thirds, but I can write it in fourths. And I can say that it's 2 pi over 4. This is also the same as saying 3 pi over 6. Or it's the same as saying 6 pi over 12. Pi over 3 is the same as 2 pi over 6. And it's the same as 3 pi over 12. Pi over 4 is the same as 4 pi over 12. And pi over 6 is the same as, 2 pi over 12. So, when I look at 13 pi over 12, I look at these numbers here, and I ask myself which one of these numbers, if I add them together, would get me 13. Do any of them?
And what together?
Like 12 pi over 12 plus 6 pi over 12 is 18 pi over 12. That's a little bit too big. So maybe 12 and pi over 12, but I don't want to do that one. So maybe I need to do 3 pi over 2, because that's 1.5 times around. That over 12 is 18 pi over 12. But I don't think that helps either. I'm trying to find a way to get to 13 pi over 12. Can anybody think of a way?
What if we just know what it is?
That it what?
What if we just know what it is?
Okay, but you're going to have to be able to write you're supposed to be able to break it up with fractions. The only special one is this one right there. So 2 pi over 3 is the same as 8 pi over 12. So maybe that. What's 13 minus 8?
5.
Okay, that doesn't help. So I'm trying to think of a way to do that. What's maybe 5 pi over 6 is the same as 10 pi over 12. Oh, that'll work. Because I can use this one and that one. And I could go from there. But those are kind of tough ones. I don't know if I will put one like that on there. Okay, so then you would break your sign up, and it would be sine of 3 pi over 12. So it'd be pi over 3 plus 5 pi over 6. Okay?
So what if you did put in these degrees, like
Okay, what is that? How many degrees is that?
195?
So this is 195, and so this right here is 60 plus, and this one is what's 5 pi over 6?
That would be,
1,
120.
135. And so it would be the same thing. When you do it, you'd be taking this angle of 60 degrees, and then this one over here at 135 is 45 right there. That's not right.
Wait, 135 would be, I mean, 5 pi over 6, isn't that, 150?
Yes, it is. So these two don't add up, do they? Oh, this is a 4. This is a 3.
But the problem of putting it in degrees, that means you have to put it back in the radians. Get rid of it.
You do. So this is actually pi over 4. So we would use the 45 one right here, and then we would use a 31 right there. And then we would follow the definition. We're just going through a review, Eli. Okay. All right. Let's take a look at a few of these. I'd like to talk about these down at the bottom because these are going to be important on the test. Okay. Find the exact value of these. So, let's see, these are. And these equations are going to be on the test too. All right, so, we're running out of time. Okay. Work through some of these. The homework I have for you